Today I'll be presenting our research investigating the impact of different pivot languages on translation quality. So first, I would like to situate our research. So since our research deals with different pivot languages in translation, it's worth mentioning that translation through pivot language is translation from language A to language C through an intermediary language B, which we call the pivot language. And this was a common practice since all time. For instance, if we look at the Holy Script, the Bible have been translated to many languages through many pivot languages, maybe most famously Latin, Ancient Greek, and many more. It's also a very important technique nowadays. For instance, the European Union is using the more common languages, which are English, French, and Spanish, as pivot languages to translate into the less common languages they have. As far as research and translation studies goes, the trend of focusing on pivot language started maybe in the 60s with the literary work, focusing on literary work. And it continued through the 70s, 80s, and 90s of the past century. Then with the new millennium and the advent of technology and digitalization, focus shifted on more areas of research, like audiovisual translation, also machine translation, of course. The use of pivot language is robust, and then there is research on that. Also, most recently, there has been research on video game localization using pivot language. So, as far as we are concerned, there is scarcity of research when it comes to the impact of the pivot languages on the quality of the final translation, hence this study. And the quality of final translation is definitely affected by the quality of the translation into the pivot language. And we utilized back translation as an experimental tool to do our research, so that we have comparable source and target text in the same language, which is English. So to do so, our research, our data included six source texts taken from multi-link database available on the Center for Research and Innovation in Translation and Translation Technology, CRITT database. And these source texts sum up to 847 words and 41 segments, were translated into the pivot languages Chinese and Arabic. And this process of translation included using a machine translation, neural machine translation system, Google Translate, then post-editing the output by native speakers of the respective languages who are also professional translators. Their second language was English, or it's English. Then we took the translation from the pivot languages, and we tried to diversify our final output of back translation. So we first used two neural machine translation systems, Google Translate and Bing, and back translated the Chinese and Arabic into English. So as you can see here, this is one, this is two. And then also we had four Chinese translators whose native language is Chinese and second language is English. and 8 Arabic translators whose native language is Arabic and second language is English, translating back these from pivot languages into English, and we call this from scratch human back translation. So there wasn't a machine involved. We tried also to triangulate. So we thought to introduce another process or task we called intralingual translation, which is monolingual paraphrasing, just paraphrasing. We had 8 participants to paraphrase our source text, as you can see in the middle, paraphrase it into English. And this could be used as a benchmark to compare the translations from the pivot languages too. To do so, so to start the comparison, we used 3 translation quality assessment metrics, and these metrics were the gold standard manual evaluation, which is commonly used in research as a standard evaluation metric. And then we also use 2 automatic metrics, namely BLEU and COMET. So the manual evaluation process, we decided on going with adequacy as a criteria. In other words, accuracy and fidelity, since accuracy errors are the most severe and most hard to detect. And then we had our framework of Likert scale, simple, from 1 to 5, 1 being no meaning is retained and 5 being all meaning is retained. Then we were lucky to have 20 raters rate our back translation. And that means that each translation segment was rated by 5 different raters. Sorry, not to mention this, so we worked on the segment levels. That's the sentence, not a whole text level. And then also, each source segment was showing to each rater or to any rater with 5 different translation candidate segments, and each translation candidate was rated from 1 to 5 by each rater. And then for all the manual evaluation scores, we calculated. We used a weighted kappa metric to calculate the kappa score, and we had a good agreement of 0.67. And then we started our analysis, and we had a 2-dimensional approach of analysis here. So as you can see on the left side, we started by analyzing the different tasks. So we started with analyzing the tasks of monolingual paraphrasing and the machine back translations from the 2 neural machine translation systems, and also the human back translations from Arabic and Chinese. And this is a more general analysis, providing more statistical analysis, and then looking into more qualitative examples to see some patterns. And then we zoomed into the pivot languages, Arabic and Chinese, and we focused here on Arabic and Chinese from the different tests. So whether it's from human translation or machine translation. And we were trying to detect any tendencies and relate them to different maybe translation universals, and also see if that affects the quality of translation. So to start with the tasks, of course, we had the average manual evaluation scores for the different tests over here, as you can see. And the manual paraphrasing scored higher than the other 2 tests, the machine back translation and human back translation. We also see a discrimination as you can see from the graph, between the monolingual paraphrasing mainly and the human-backed translation. We will get into that and the possible reasons why or explanations. Then we noticed that translation quality assessment research seldom delves into comparing the different weights of BLEU when working on the different scores. So we thought we just look at the different scores of different weights of BLEU with our data that is segment based. So we saw that on contrary to the cumulative 4 gram BLEU weight that is used as a default, cumulative 2 gram showed more or better correlation with the manual evaluation gold standard. And QM2 is only second to 1 gram. And we would like to see in our data the collocational information patterns of that. So we excluded 1 gram and we decided to go with QM2. It's also worth noting here that COMET score is correlation with the manual evaluation is not as good as QM2. So QM2 still correlates better with the manual evaluation. Then the distribution of the QM2 version or variation of BLEU here with the different tasks that we have, we also see that monolingual paraphrasing, like the gold standard evaluation, monolingual paraphrasing has higher scores, also followed by machine-backed translation and human-backed translation. And this discrimination that we noticed in the manual evaluation is even more apparent here with the BLEU score, as you can see from the distribution of the graph. Then for COMET is different. COMET shows better scores for the machine back translation, followed by human back translation, and lower scores for monolingual paraphrasing, which looks like a different pattern. But in the different metrics that we had, whether it's the manual evaluation or the 2 automatic metrics, we see that human and machine-backed translation have similar distributions, which are different than the benchmark that we used, which is the monolingual paraphrasing. So we decided to look into examples, into more depth of the data set. So as you can see here in the example, the different tasks for the human back translation, QM2 scores relatively lower than the average score of QM2 with this particular task. And unlike COMET and manual gold. And we attribute this to the sentence being longer and less exact matches. And as we know, COMET BLEU works on exact token matches, and while COMET was able to give a higher score since it maybe works in the vector space of synonymity. So as we can see, for instance, the purple word possibly and could, maybe COMET was able to detect that this is a similar word, a synonym. As for the other tasks, we can see that all the different tasks were scored high on the different evaluation metrics, except for maybe the manual evaluation for the paraphrasing. Maybe the typos justifies this with that instead of them. Here, we started to look into the different pivot languages. And the distribution here, as we can see, the manual evaluation and BLEU and COMET they have similar. We see similar tendencies. We see that the Arabic and Chinese have similar distribution with lower average scores than the monolingual paraphrasing, which shows different tendency or distribution. Sorry. But with that being said, we see that the different pivot languages have similarity of distribution, but that means they have maybe similar quality, or would that affect the patterns of translation? So to look into examples, we can see here that the source word nomadic in this reference segment was translated literally by the monolingual English, and in all cases, so 62.5% is the same literal translation, and for the other translation variations, it's still the same lexeme of nomad, and that's why we think it's always scoring higher, because maybe there is this more literal tendency of translation by monolingual paraphrasing, since the process itself is introducing more priming effect of the source. So the source text English primes into the target English, since the process is just monolingual paraphrasing. It's the same language. While in Arabic and Chinese, we see different patterns. Most of the cases, it's not literal, it's more free translation. So as we can see here, is 62.5 for Arabic, it's different variation, more free translation maybe. The same for Chinese, 50%. But what is worth mentioning here, or noticing, is the word Bedouin in Arabic. Bedouin, which is roughly translated to the Arab nomad of the desert, which is particular maybe to Arabic culture, but it was translated into Bedouin, and we took a step back to look at the translation into pivot to see whether the pivot actually affected this kind of translation. So we saw that the post editor actually translated the word nomadic into Bedouin, and it was probably a subjective choice, which is a sort of normalization process, one of the translation universals. And this translation was reflected in the back translations by the 8 different translators, or most of them, which also might show a shining through of Arabic, the pivot language Arabic, into the final translation. So this is one impact of pivot translation into the final translation. The same goes with Chinese, moving and drift from place to place. So this is also a shining through of Chinese into the final translation, back translation Arabic. And then after we established that there are differences between pivot languages, whether it's quantitatively or qualitatively, and the monolingual paraphrasing, we try to see if different pivot languages introduce different versions. But it's just worth mentioning that this doesn't affect like quantitative analysis. Scores, as we can see, are similar distribution. But then qualitative tendencies are different, as we can see from this example. So this example, the word disliked in this segment was translated by the Arabic translators back into English into hate, different versions of hate. And then for Chinese, does not like. So there are some qualitative differences. And this is also shining through the back translation. To wrap up our main observations here, that monolingual paraphrasing, as we said, has best scores, since maybe it's more literal, there's more priming effect than the pivot language, which might introduce more free translation. The other thing, which is very interesting, is that the neural machine translation system's output achieved similar scores to the human-backed translations, which is something that can also be further studied. And also, we see that our cumulative 2-gram blood weight has better scores with our data set than the default CUM4 gram or COMET. That is in correlation to the standard manual evaluation. And then also, despite these qualitative differences between the different pivot languages, Arabic and Chinese, we see that the automatic metrics did not separate between the different languages with the similar distribution that we saw in the different graphs. And here are some references. And thank you.